They should have said the poet. The poet. They should have said the poet. The poet.
This is Sending Poets, a podcast about ideas. Our goal is to understand metaphorical truths within the beauty we find in the human experience. Sending Poets. The relationship between our evolution and dimensions. Wow. My name is John. With me is Bob and Tucker. Good morning, you guys.
How's epic?
Good morning.
And today we're going to
This watch. You see this watch?
Yeah. It's your father's watch.
Your father's watch.
We're going today. We're gonna dig back into the mind of Bob and some really cool physics ideas he's been contemplating on that will likely relate to other stories in future episodes. So with that, I will turn it right over to you, Bob.
Thank you. I don't think you can never top that. That's going to be
Wow.
the best haiku intro of all time.
I mean, it's like a one-word impression. If you're gonna try to do Christopher Walken, wow, Anyway,
That haiku is what's gonna put us ahead of the Hawk to a Girl
Yeah.
you heard it
in
here
the
first.
podcast
Yeah.
world. Yep.
Oh yeah, we're climbing to the top. I'm not gonna go there. There's too many ways they can go there. Climbing on top of the hawk.
Yeah, right. There you go. Yeah.
Okay, guys. Let's go way back and start with like everybody knows Pythagorean theorem, right? A squared plus b squared equals c squared.
Yeah.
And this is the two short sides of a right triangle in relation to the hypotenuse of the right triangle. Okay. Well, I listened to this podcast recently, and I'll shout it out. It's Sean Carroll's Mindscape. Highly, highly recommend. And he talks about secrets of Einstein's equation. And part of the beauty of this was how he went back and was going through some of the mathematical underpinnings of Einstein's equation. And this is in relation to curvature of space-time and the energy of space-time, etc. So without digging into that, which is not where we're going, I did like where he went with some of the foundations of these ideas, and they start with these mathematical postulates, and they are built upon over generations of mathematicians. And so in the beginning, Pythagoras had this postulate called the parallel postulate. And it seems so simple. It's just like so simple. Parallel lines exist. So obviously parallel lines, without going into the wonky mathematician type definition, which is just painful to listen to. Obviously, we all know what a parallel line is. So two lines that are, X distance apart will remain that distance apart for all time as far as they extend.
Perpetually equidistant.
Thank you. Perpetually equidistant. Very precise. Okay. So imagine you have two lines that are perpetually equidistant. From that postulate, a bunch of geometry can be built upon. But there's more. So you end up with Euclidean geometry. This is coordinate based. We all can imagine the Euclidean graph of X, Y, and Z, etc. And ways to extend these lines through a spatial environment, right? So you have a coordinate system that you could extend these lines through. Then there comes another layer, which is this guy's, hopefully I don't murder his pronunciation, Riemann, this mathematician who creates a new kind of geometry within the Euclidean framework of the Pythagorean parallel postulate. And that is it true that, parallel lines are forever parallel? Like, what if they're not? Let's just say, what if they're not? So you have these parallel lines that are equidistant for all time as far as you extend them out. Okay, that's fair. Let's just say that's a flat geometry. You're just going to get a flat, like if you have a pool table and you just extend these parallel lines, you draw up the XY coordinates and you just extend that forever in a Euclidean geometry. Everything works and everything's beautiful. This guy, Riemann or Riemann, I think it's Riemann. He understands. Well, let's play around with this thing. So, what if the more you extend the line after a great distance, the two lines come together more and more? So the concept would be, say you're on Earth, you're on the equator, and you start two lines going, one to the north, one to the south, and they look pretty parallel to you. But if you keep extending them, eventually they all will pass through the north and the south pole. Can you imagine that? You understand what I'm saying?
Yeah. Like, if it was truly parallel, then they wouldn't pass through the same point, because by definition, that one point can't be on both lines if they're both parallel lines. The one point only exists on one of those lines.
Exactly. So that's spherical geometry. So if you're on a sphere, even if you start it, and by the way, we talked about this with some of the other dimensional concepts about what may look flat to you. If you pull back far enough, you can start to see some curvature, right? This is what we've been talking about many, many times. Like what looks like a flat plane, like living on the Earth. It's such a giant sphere compared to our relatively small size. You could stand in the middle of a desert and say, look, it's flat. Obviously, it's flat. Look all around you. But naturally, if you pull out and go higher and higher and higher, you see the curvature. So the same thing happens. You start with a parallel, seemingly parallel pair of lines. And if they come closer together, there's this positive curvature that ends up becoming spherical. That's spherical geometry. Flip side then is, what happens if the lines forever deviate? So you could have lines that will not come together at
a single point. They just continually get further and further apart the further the line goes on, you're saying, right?
Yes, and as they do that, they end up with a different shape. So instead of a sphere, it ends up shaped like a wobbly poncho or a saddle, where it ends up having kind of a dip and some flaring going on, and that's called hyperbolic space. So hyperbolic space is negative curvature of space. And so, after listening to this podcast and understanding these are all built upon these postulates, like a very simple axiom or postulate that a mathematician, by the way, this is all based on mathematics, so it doesn't necessarily have any tie into reality. This is one of the great gifts and curses of mathematics, is that it's like a language. It's like an abstraction. And so it might describe reality, it might be a quantitative version of what we live in, and it might be completely fabricated. It might just be like, like a poem or something. I mean, there's literally no necessity for a mathematical axiom to be true in the physics sense. Now, obviously, I think we could all agree that in the modern era, we've combined, mathematics and physics into a technological proof of, the feasibility of using quantitative language or mathematics and formulaic understanding of the laws of the universe, physics, to create technology and to do things. So let's just say there's some crossover there, where the ends are, specifically say string theory, which is a heavily mathematics-based concept of physics, like a theory of everything. But what does string theory call into question is our description or definition of dimensionality. So string theory, and we're going to hammer, three-body problem to no end, of course, but three-body problem brings this into a narrative context where the presupposition is string theory is true. An alien race also knows string theory is true. And one of the cores of string theory is the number of dimensions required to make the mathematics work, and the number is 10. Sometimes they say or 11. There's this thing called M theory, where you have an 11th dimension, which is a membrane that the 10 sit upon. But let's just say 10 for sake of argument. So string theory has these 10-dimension requirements. So humans are like, well, we have length, we have height, we have width. We're calling length, height, and width a dimension. And then back to Einstein. So this goes back to Einstein's equations. He does likewise length, height, and width, and then time. So Einstein and his friends come up with these ideas called space-time. And such things as gravity are the curvature of space-time. And objects are traveling in a straight line relative to their understanding. This is general relativity. They're traveling in a straight line, and the curvature, the wobbliness of the fabric of space-time itself is what puts them in orbit like Jupiter around the sun. So the sun creates this big distortion in the fabric of space-time, and the gravity, doing air quotes now, is just like falling. So falling and gravity are, acceleration due to falling is the same as gravity, and gravity is like falling due to curvature of space-time. So these objects are moving in a straight line path, just like you fall towards the center of the Earth. And they're all on these geodesic paths, etc. So no argument there. That's not my point. My point is bringing in new postulates to define dimensionality. So imagine we start with spatial dimensional postulates. So length, height, and width. Length, height, and width. We've talked about this many times as well with the solution to the three-body problem series that we did. Just overview again. So we have, I'm calling it a direction to differentiate from a dimension. So a direction of length, or the x-coordinate in the Euclidean sense. So you have an x-coordinate is length, y is height, and z is width. So the direction of length, by definition, is not a. We restate this. So let's just say the first spatial postulate is that length, height, and width are considered a direction by definition, not a dimension unto themselves. So these are not considered dimensions. And this is part of the trying to redefine how to adapt into something that makes, say, string theory with the requirement of 10 dimensions work and make sense without having to call upon tiny little micro rolled up dimensions or higher macro dimensions that we don't have experience of either. Second postulate is that the dimensions are constructed by the conjunction of directions. So layering these directions is what creates dimensionality. And then the dimensional expansion progresses as 2 to the n, where n is the number of directions. And we'll get into that a little bit here in a second. But imagine length. Let's just start with length. So along length, let's have an origin point of 0. So length, or the x coordinate, you would say there's an origin point of 0, and then you'd have a plus side and a minus side, or a negative side. So everything arbitrarily to one side of the 0 point would be positive length, and to the opposite side of 0 point would be negative length. So you have 2 to the 1 directions. So 2 to the 1, so 2 to the n, and the n is 1. So 2 to the 1, which is 2. So you'd have one dimension, which would be the positive part of length, and the second dimension would be the negative component of length. Add in the second directional coordinate of height. So now you have length and height. So your n equals 2. So 2 to the 2 equals 4. So you're going to have 4 dimensions, spatial dimensions. So you're going to have now like an X on a map. So if you take a flat piece of paper and you draw a vertical line and a horizontal line, and where they connect is the origin, 0, 0. And then you have essentially a quad system where up and to the right would be plus height and plus length. Down and to the right would be negative height and plus length. Up and to the left would be negative length, positive height. Down and to the left would be negative length, negative height. Does everybody see that?
Yep.
So then we're defining dimensionality not as a function of there's 2 dimensions of height and length, but we're saying the dimensions are the up and to the right, down and to the right, up and to the left, down and to the left. Add width. Now you have 2 to the third power. So 2 to the third power is 2 times 2 is 4 times 2 is 8. So 2 cubed is 8. And now, without boring everybody and going through all the permutations, imagine you have, I'll just do the front side for ease. You have 4 blocks, like kids' blocks, 4 cubes. And if you stack a 2 by 2 wall of cubes, that's like the X direction coming at you, or positive length coming at you. And then you would have, along positive length, you'd have positive height and positive width, which would be up and to the right. Negative height and positive width, which should be down and to the right. Positive height and negative width would be up and to the left. Negative height and negative width would be down and to the left. And this is all along positive length. And then that doubles along negative length. So you have 4 coming at you and 4 going away from you. So that's 8 dimensions. And then this can be expanded out. So now imagine you add a hyperdirection. So we're kind of stuck with the inability to visualize or create terminology about directions we can't look in. Kind of analogous to if you're stuck on a piece of paper, you can conceptualize north, south, east, west, but you can't conceptualize up and down.
Yeah.
It just wouldn't make any sense. So we're stuck right now. Let's go to the point of, okay, so we're stuck, but how does it work? Does this continual 2 to the 4th power? So if we add one more direction, let's just call it hyperlength. So hyperlength would be like X prime, adding another length dimension. And the way I conceptualize it is, instead of in Euclidean, you would have all these angles going perpendicular to one another, make the length into like an X through the origin. That makes sense? So an X through the origin where your length is now at an angle. So instead of it being quote unquote flat, it would be like
at a 45-degree angle, maybe, let's just say, like that kind of X. Yeah.
Exactly. But then along each of those splits, you would have then the height and the width. So 2 to the 4th is 16 dimensions. So 2 to the 4th power is 16. So you're going to take everything we just calculated, which was 8.
Yeah.
So along length, you have, the height and the width through the 4 permutations on the positive length and the negative length. So now just double that. Just take that X. And now, like you said, instead of it being kind of flat, it's out at a 45-degree angle through the origin. But each of the X's, they each have 8 dimensionalities, 4 on the positive side of X and 4 on the negative side of X. So that's 8. 2 of them in an X formation now make 16.
Mm-hmm.
And you can keep doing this then, obviously, by making a hyper height and a hyper width and keep expanding the geometry. It just gets harder in your head to do it.
Yeah.
But if you can visualize to this point, I think you're pretty much there. Has everybody got that visualized?
Yeah, I think so. I mean, I think I got the that hyperlink thing, but it's possible that what I'm thinking of isn't exactly the right thing. But I mean, I see something that I think is.
So instead of just starting with the x-axis, now I'm confusing terms. Instead of just starting with the length being flat, just take that and extend it. This is how I do it in my head. Like I take the quadrants and I put them at the end of the x. So you stretch out the length, and so you have a box at the end of positive length and a box at the end of negative length, and each box contains 4 cubes. See what I'm saying? So just do that twice, and then put them at a 45-degree angle to each other through the origin. So you make like a big X, and at the end of the first X, on the positive side of length, there's 4 cubes, and there's four more cubes at the negative side, and then both of those you have a duplicate, and it passes through the origin as well, and that's how you get to 16.
Yeah.
Hard to do.
Okay.
Hard to do on a podcast, everybody, but there you go.
Well, sure. And again, like part of the whole thing is we're 3-dimensional, or yeah, I guess is it fair to say we're 3-dimensional creatures? I mean, that's how we kind of perceive reality, and we're talking about perceiving things outside of what we're evolved to. So it is like, whether it's a podcast or anything, just trying to wrap your head around this is kind of.
It is. There is a sense of visualizing outside of what you're capable of.
Yeah.
Right. I agree with that.
Very gnarly.
Back into the terminology, the devil is in this detail, meaning what if the problematic nature of string theory is that we've just misdefined what dimensions are and how the dimension applies mathematically. Like we're trying to come up with something we don't need to come up with. That's what I'm trying to get to. So if you redefine we're not 3-dimensional beings, we're 3-directional beings, that would be the point. If you can see that point, I think this progresses smoothly. If you can't see that point, then it becomes sticky.
Yeah.
But the concept of the arbitrary nature. So when we talk about a postulate, it's just somebody saying this thing is the way it is by definition. Okay? It doesn't have to be real. It's a made up thing. It's like saying the word duck or the sound duck means, a little bird that floats in the water and swims around. It's like, it's not really what the word sound of duck means. It's just what we call ducks. Like there's an arbitrary nature to the language itself. It's an abstraction. Mathematics is an abstraction. It's not necessarily tied to a reality. So if we've been, quote unquote, mispronouncing duck this whole time, we didn't realize it has a different name, waterfowl, whatever you want to call it. I don't care.
Yeah.
But my point is, what if it's so simple that we've just misapplied a definition from the get-go that a direction is a dimension? Because I don't argue we have 3 directions. That's not my contention is not that we have 3 directions. My contention is the combination of 3 directions leads to a 8 spatial dimensional universe. So that segues into the next set of postulates, which have to do with time. So going back to Einstein and his friends, the concept of space-time, where time is a dimension in and of itself. And I would say that could be applied with another set of postulates, this temporal dimensional postulate series. So say time is the twist of a direction. So just like a hands on a clock going around clockwise or counterclockwise, the cycling of a twist, so it's not going outside of its direction, it's twisting along its axis of direction. So it's not adding anything spatially, but it does take time to go from 12 o'clock down, 1, 2, 3, 4, 5 o'clock rock. No, sorry. It goes all the way around into a rotation of either clockwise or counterclockwise. Okay.
Yeah.
And so the postulate then is that time cannot exist where there's no direction of oscillation of a waveform. So it requires a minimum of 2 directions. So a flat line is considered timeless. So what that means is if you have one direction of length, it's going to be a flat line. So even if you live on that line, there's nowhere else you live, it's going to be flat because it cannot process in a wave-like fashion. It cannot go into the height direction. So in order to perpetuate a wave, like to propagate a wave on a line, even though it's a single like x-axis line, it needs to be able to undulate or propagate through height.
Yeah,
That makes
okay.
sense. So you can have like a straight line, like a rope, and if you hold that rope taut, guitar string, pardon me. Why can't I just go to the easy one? You have a guitar string. A guitar string unplucked makes no sound. Now, the guitar string is only strung in one direction, but when you pluck it, you propagate a waveform, and that wave undulates through a second direction, which would be height, right, to create this waveform. So it's akin to that. So the postulate is that time cannot exist where there is no direction of oscillation of a waveform. So it requires a minimum of 2 directions, and a flat line has no time. Time is a dimension, it's the third postulate, and it too expands. So we have this expansion or addition of the dimensionality of time. It can grow. And the formula for the expansion of time is 2 to the n minus 2, where n is the number of directions. So 2 to the n minus 2. So length alone is a single direction. And even though it has 2 spatial dimensions, positive and negative length, it has 0 temporal dimension. There is no time associated with a flat line. 2 to the 2 minus 2. So 2 to the 0 is 1. So 2 to the n minus 2, or 2 minus 2 is 2 to the 0, and that's 1. And there's a single time dimension corresponding to length times height. Length times height times width is 2 to the n minus 2, which is 2 to the 3 minus 2. So that's 2 to the 1, and 2 to the 1 is 2. So when you have a length times height times width system of directionality, you have 4 spatial dimensions along positive length and 1 temporal, makes 5. And then along negative length, you have 4 spatial dimensions and 1 temporal, which makes 5. Put those together, you get 10. So in our current state of 3 directions of length, height, and width, you would have 1 temporal dimension along the positive x-axis and 1 temporal direction upon the negative x-axis, giving you a total of 10 dimensions in the present situation that we find ourselves in. Thus, that would be the solution to the string theory formula requiring 10 dimensions without requiring micro or macro dimensions. And by the way, let me state this here. It is difficult to conceptualize this as I'm breaking it out in a graphical representation. I'm saying these are all laid over each other, one on top of another. So as I talk about like the 4 quadrants of, length and height and width, and you can break them into the 4 quadrants along positive length and 4, I'm saying they all essentially kind of stack on one another, and the breaking out into a graphical representation is just for our benefit to visualize.
Gotcha.
So imagine you have superimposed the 4 cubes or quadrants along positive length, all stacked on one another. Much easier to break it out into quadrants, so you can individualize them. But imagine it's all stacked on one another, and then you have the twist along the x-axis, is your one dimension of time. And then there's a mirror image of that going the opposite direction from the origin along negative length. And now let's project further. If you had length and a hyperlength dimension, going back to making X in an X format through the, shouldn't keep saying X, you have length going
cross or something.
Thank you. Cross, as a cross through the origin, right? And then you would have height and width. So now you have 4 directions. So 2 to the 4 minus 2 equals 2 to the 2, or 2 squared, which equals 4. And obviously then you would have 4 temporal dimensions. So you'd have 2 of time coming along positive length and positive hyperlength, and 2 more of time going along negative length and negative hyperlength. And you could keep on doing the math. If you added another directionality, let's just say not just hyperlength, but hyperheight, now you would have 5 directions. So you'd have 2 to the 5 minus 2, or 2 to the 3rd, which would give you 8 temporal dimensions. Okay, a lot of crazy shit there. Sorry, guys.
That's good.
Someone wake Tucker up, please.
Oh no, I'm good. I'm just painting coordinate planes in my head.
I get you.
know.
I'm gonna put it together.
No big deal.
No big deal. So here's where it gets spicy. Okay, we introduced 2 concepts. One was a postulate system for spatial dimensionality, and the second was a postulate system for temporal dimensionality. Now to put it together, this is where it gets. I kind of already covered this for the string theory concept. But if you have one direction, that equates into 0 time dimensions and 2 spatial dimensions. So one direction gives you 2 total dimensions. If you have 2 directions, you get 1 time dimension and 4 spatial dimensions, which gives you 5 total. 3 directions gives you 2 time dimensions and 8 spatial, where you have 10 dimensions. This is the solution to string theory. If we stack another direction on that, now we're going to look in a direction we can't look in, just like analogous to you're on a piece of paper and someone says, look up. Well, we're in 3-dimensional paper, if you will. And if we can look up and add another direction, another up and down, we would have 4 time dimensions and 16 spatial dimensions, which gives us 20 total dimensions. So 2 times 10 is 20. So it's a doubling effect. If you go to 5 directions, you're going to get 8 temporal and 32 spatial, gets you to 40. 5 directions, sorry.
5. No.
Yeah.
6 directions.
Now 6 directions, thank you. You would have 16 time dimensions and 64 spatial, which gives you 80. So you can see the pattern goes as a doubling of total dimensions.
Yeah.
So after you get to 5, because there's no temporal with less than 2 directions. After you get to 5 to 10 to 20 to 40 to 80 and so on. So there is what I would call symmetry here that is aligning space, time, and then space-time. And then as you add directionality, it doubles the total number of space-time dimensions indefinitely. So the concept then is one of mathematics and not physics. I mean, I think there is something here, but obviously you can't. I mean, we're talking about 2 things. Number one is redefining direction from dimension, and so it's arbitrary. I don't know who gets to set the definition. I don't know, not me, I guess. But it's essentially a definitional argument just at that standpoint. And number 2 is the prediction of higher levels of directionality would encode higher levels of dimensionality with a prediction, formulaically, that the universe operates like this. So that's more based on physics, and the search for higher dimensionality would continue. So
can I ask a question here? That might be a good point. Just going back to Sean Carroll, I know he's a big proponent of like many worlds theory. Is there a correlation here with like the idea of these extra dimensions and and many worlds, do you know, or are those kind of separate? Like, in other words, like, because I'm just trying to, yeah, like, wow, 20 total dimensions or 40 total dimensions is like, is some of this idea about like if there is a parallel universe or whatever?
Well, just remember, we're in 10 right now. So I just unified the contradictory nature of, we think we have 3 spatial dimensions and 1 temporal, but the math says we should have 10. So I did make it simpler by saying we are in 10 right now. So that's the first shot, is that we have this paradox of there are some really good solutions and predictions made by string theory, but it requires 10 dimensions, and we don't see 10 dimensions. So how does that reconcile? And so they're redefining directionality and dimensionality and a little bit of imagination of a negative length zone of the universe, if you will. That does take a leap of faith, I guess you could say, at this point. But yeah, having a reflective negative length component to the universe, then that does reconcile what we see with the math. But directly to your point, John, great question, by the way. Many worlds theory is tied into this inflation period of the universe. So we have the Big Bang, which in and of itself is unfalsifiable and unverifiable, because it's like this point before we have evidence. There is no direct evidence from, I believe the estimate is about 370,000 years after the Big Bang is kind of the beginning of light. I mean, that's the beginning of the cosmic microwave background radiation that we can detect. So there is no direct evidence for any time before that. Just like a collapsing star, you can kind of see a star collapse, but you can't see in a black hole because it's a singularity event and it's trapped behind a event horizon, which is a maximally curved region of space to infinite density and infinitely small volume, such that we have no direct evidence of what's inside the event horizon of a black hole. We can just see the effects of it after the fact. So back to the question. The concept in standard model right now is that there is an inflation field that expanded from the initial moment of the Big Bang to this period where it stopped inflating at above light speed. So there's like an initial expansion event that happens. And this initial expansion event is considered as analogous to like a quantum fluctuation. So in the vacuum energy of space right now, we have these quantum particles that will fluctuate into and out of existence. And there's like a particle and antiparticle. And if they collide, it becomes just energy. But the energy in the vacuum itself creates them spontaneously. So it's like a fractal concept of this field of creation and expansion called the inflation field. No evidence for this, by the way. Just like me making up dimensions and directions. But the concept is this event happens a multitude of times, an innumerable number of times, and this is the many worlds theory. So the many worlds come from an infinite number of spontaneously generated quantum fluctuations that create universes akin to ours, each one with their own parameters of the laws of physics. So we have this problem in physics, which is how precisely all of the laws of physics are, all the constants in physics, all the weight of the proton, charge of the electron, all these little things, the Hubble constants, the expansion rates, the energy density of the vacuum space itself, all these things are extremely finely tuned. It's called the fine-tuning problem, where the universe is so finely tuned. And so the way the standard model fixes this is by this inflation period. So we have a many worlds theory, whereas imagine you have an infinite variation of spontaneous universes popping into some greater universal matrix, and ours did that too. And it's propagated by this inflation field, and each one uniquely has its own set of laws of physics. It has its own set of constants. You know, what the weight of the electron is, and charges, and vacuum energy of space, etc. All these things are essentially randomly assigned an infinite number of times. The concept is only in the universes that have a balance that's so finely tuned, that is so precisely dialed in for stability and the building blocks of life, could ever have a living creature evolve within it to then look back upon it and see it as that's the laws of physics of my universe. So we have this combination of this inflation period and the fine-tuning problem of the universe. Both of those are fixed with the multi-world theory through this moment of the Big Bang, through like the first 300, Google check me, like 370,000 years, I think is what they're calculating right now. So the first 370,000 years is essentially without you, we cannot look back into this, like the universe is too hot and it's inflating too fast, and we have no evidence of what happens before that period of time, where the first thing we can see is the CMB background radiation. And so that's how the current standard model gets around implementing a many worlds theory, is through this inflation field and fine-tuning paradox.
Yeah, it looks like 380,000 years at least is what the Google AI overview pulled out immediately. But then, yeah.
But that's where they come with, meaning the standard model scientists right now come with this multi-worlds theory. So a lot of people think it's like has to do with, you make a decision, did you go left at the stoplight or right at the stoplight, and there's like a divergence there, and you get a second universe. That's not what they're talking about. That's like Marvel Comics shit.
Okay. That's good to know.
It might be real, but it's also in a comic book, so take it for what it's worth.
Yeah, or a multitude of stories like Dark Matter. Great example of that kind of idea. And anyway, yeah.
But the physics underlying it is an explanation for how we inflated from a singularity to everything we see today, with the continuation of expansion, but also laws of physics being established so precisely and well balanced that why is the neutron the way it is? Like, why is anything the way it is? So this multi-world theory allows for an infinite variation of rules of physics, and only the ones that are stable enough to support the fine-tuning that we see before us would allow for life to evolve.
Okay. Yeah, interesting.
Which I disagree with, by the way. If you want to do a follow-up of what do I believe, I'll take that.
Sure.
I was going to say, I think that's an arrogant take from humanity's point of view to say life wouldn't evolve in a universe with different physical limiting traits. It's, we don't have computers capable of modeling universes and accurately modeling how life might develop elsewhere. It's just, you got a group of smart people who say, we don't think this could happen, so therefore it couldn't happen. And it's like, whatever.
Yeah.
25 years, you could be singing a different song about that.
Yeah, totally.
I agree with that. Let me make the devil's advocate case. There are some instances where you play around with the values of these constants, these laws of physics. If you play around with the strengths or weaknesses or charges or whatever, and and this is according to the wisdom of humans. So to your point, we are filled with ignorance, and I think we could be missing the boat here, obviously. But in the models that are based on our current physics, the fine tuning is so, like, let's say you have an amp, right? And say it goes, I got to do this, 1 to 11, right? So you got an amp, and it goes 1 to 11. Spinal Tap.
Yeah.
You gotta imagine, like, if you adjust that thing by, like, you just look at it, you don't even touch it, like you just blow from across the room, like if you just barely change the mass of a neutron, the models show like the universe never expands, like energy and matter don't diverge, everything collapses on itself. Like, so there's an issue. I agree with you that we are filled with ignorance, but there is a very fine balance that can be currently described as one of two things. Either we were designed intelligently, like this was created for a purpose, or this is also one of the arguments for the simulation theory, is that everything is so precisely set up, like a house of cards. If we just blow on this thing just a little bit on one of the variables, the whole house of cards comes down. So that means either we're not really in a real universe, we're in a laptop somewhere, on some alien kid's desk doing his homework, and he's just making a universe for science lab or whatever, or multi-worlds theory or whatever. But I do grant that we're filled with ignorance. I think that's the right take-home message, is these are all just, rationalizations and narrations that try to back into something without knowing it's the root or reason behind it.
Yeah.
So
To continue the Spinal Tap thing, although I don't know that this is really any different, but you said if you have this scale and the parameters go from 1 to 11, well, what about this one that goes to 12? This one goes to 12. I mean,
It's
yeah,
I agree. I know. I think Tom is exactly right. We don't know enough to know what we don't know about this thing. And so to be so arrogant and filled with hubris that we know what can't happen, I think that's the worst thing you could possibly say, by the way.
Yeah.
Is this can't happen. I think that's so dickish. Like that's being a poor reflection on dickheads, by the way. That's just like, that is.
It really is the Spinal Tap thing. It's like someone saying like amplifiers go 1 to 10,
exactly.
period.
Yes.
And you're like, but this one goes to 11. Well, and the joke is like, but couldn't they just have changed the label, the numbers on the dial or whatever? but this one goes to 11. But I think there's still something interesting there, isn't it? Like,
it is.
Like you said, we don't know what we don't know, and like to just be like, well, no, this is the range, period.
The bedrock, the bedrock of my argument is the amp goes to 11. That's the literal bedrock.
Because my thinking is, yes, you change certain parameters, you don't have a universe where molecular bonding can happen, or where electromagnetism doesn't work the same way. But given an infinite amount of time, who knows what develops? Like something could be there. It's not going to be anything like what we call reality, but it doesn't mean that there isn't a reality there.
Yeah, because our reality is based on the way our, time, I guess, as best we can tell, has evolved over all that. Like you said, this massive amount of time, and the way life evolves over that time, and things change over that time, and like a butterfly effect kind of thing. Like, well, what if this one thing was a little different? Would that have this? Drawing a blank on the word. We were just talking about too, like in terms of money, but exponential, like this exponential compounding effect from just something hundreds of millions of years ago being slightly different,
Or it could be balanced out, like counterbalanced, where maybe no single variable changes, but like two will change in symmetry.
Yeah.
Right. So if we end up saying, like, if you adjust the charge of electron a little bit, black holes don't exist anymore. Well, what if you also change, the charge of a proton at the same time? I don't know, like whatever, like we're dialing like we're God at this point. So
maybe you end up with a universe with no matter, but sentience exists as vibration.
Yeah. Right.
Let's piggyback off that, because that was going to be like I kind of begged the question of, if we're all throw crazy shit against the wall like scientists do, talking about quantum fluctuations and inflaton fields, let me have a shot at this thing. Okay, so here's my shot. Everything is a wave. Okay, there is no physical matter. Everything's a wave. and the universe starts Big Bang style as a conjunction of two giant waves on the background membrane of the bigger universe, whatever that is. We're talking in, poetic language here. So here we go. So imagine you have two waves, like two gravitational waves, okay, that are rippling through space-time itself along the membrane. And when they strike each other just right, at the right frequency, Tucker, instead of passing through each other or canceling out, right? Because we all understand wave theory. You can have waves that pass through each other or cancel each other or amplify each other, right? We all, without going into that, do we all understand what I'm talking about?
Yeah, I think so, yeah.
So you could have two waves combine, and that's the moment of creation. Meaning, instead of having a big bang from nothing, there is something spontaneously. You have actual things existing. Now, where do they come from? I don't have an answer for that. So I am still kicking the can down the road. But to me, it's a better explanation of two things that we don't have an explanation for coming together to create what we see today, other than, nothing from nothing, no time, something happens at some time and creates everything we see today. So I'm kind of like splitting the difference here in that I'm doubling the amount of uncertainty, because now you need two things instead of one big bang. You essentially need two events to start the game. But imagine you have two events that are always in motion, always perpetuating for all time. So no start or finish. But if they ricochet into each other at just the right frequency, time, place, amplitude, etc., they combine and split from, say, a propagation of a waveform on 2 dimensions. By the way, I'm using the classical definition of dimension, not the one I just stated. So they collide at 2-dimensional. Well, maybe they then split and form a 3rd dimension. So imagine you have a rope, or let's just say more accurate, a piece of paper. You have a piece of paper and it's vibrating, and you have one waveform from the east and one waveform from the west. And when they smash into each other, they create an up and a down. Does that make sense?
Yeah.
So imagine you have a paper-like universe, so you have length and height, or length and width, but no height on paper. But you do have a motion of the paper, waves, and instead of them passing through each other or canceling each other out, the peak of one wave hits the peak of the other wave, and it bursts into a extra directional wave. Now you have a height component, and that's what I'm claiming is really happening here with the Big Bang. Is we don't have an inflation period from a infinitely small, infinitely dense quantum particle popping into existence from nothing. We essentially start the game at 380,000 years after the Big Bang. So what we look at is the start of the game. Scientists are extrapolating before 380,000 years to zero, just like they extrapolate from a black hole, that there is some unseen singularity inside. What I'm saying is it's not. It's fractally the same as the universe, where it's the outside is where everything is. So it starts from the outside position. It never starts from a singularity position, which I think is mathematically untenable, because you end up with infinities which don't exist.
And the two Y2 waves, I mean, that's just what you're saying, that collision, but it's not like, am I correct to say that it's not that there was only two waves, it's just those are the two waves that happened to collide into each other, but maybe were many other waves that, just didn't have that exact right moment of collision, so they were passing through or amplifying or canceling, and all this was happening, and it just happened to be these two, or are you kind of, is the supposition that there was just two waves and just eventually they smashed into each other, but it was only two waves?
I have zero evidence for either, so I kind of sit on the simplest answer, which was these are the two ways that these are the two waves that created our universe. My gut tells me there's an infinite number of waves on the bigger membrane, and it happens over and over and over again. And each conjunction of the waves is what sets the physical parameters of that universe. And by the way, the game expands, meaning if we have a three-dimensional wave hit another three-dimensional wave, what do you think happens?
Oh yeah. Well, for some reason I want to say like 9 because I 3 and 3, but I don't think that's where you're going, right? Like,
well, we get into what we just talked about with adding another direction. So when we say three-directional wave, when a three-directional wave hits another three-directional wave, it creates a four-directional space.
Okay.
So you start with, say, two directions. That creates us, which is the Big Bang that makes three-directional space, which has 8 spatial dimensions, 2 of time. Then you do it again. Then you get to 16 and 4. So you have 16 spatial and 4 temporal. So every time you get a conjunction, so we have these things called gravitational waves. These are very well documented. This is not sci-fi. This is sci-fiction or sci-fact. That the fabric of space-time gets wrinkled up and waves will propagate with massive conjunctions of matter or energy. So black holes merging, right? Supernova, these kind of things create a signal in the fabric of space-time, not an electromagnetic signal, but a detection of the shrinking and expansion of space-time itself. So imagine space-time is a thing like bread. You know, like the bread is the batter is baking, and an analogy for the universe is that we are in raisin bread. So if we're in raisin bread, as the batter is baking, all the raisins get a little farther from each other, if that makes sense, right? So none of the raisins will ever get closer to one another from the batter as the batter bakes in the pan. It will foam up. And as the batter expands, all the raisins get a little bit farther from each other. So in that metaphor, imagine you like are jiggling it. So if you have a detector inside the pan and you're jiggling the batter, that's the gravitational wave. So we have these giant interferometers that measure the precision of their location one to another to some ridiculously high level of precision and accuracy. And the ability for us now to detect a black hole merger, excuse me, is that these things will come out of alignment of their direction, that they know they're a certain distance from one to another. And it goes in a wave pattern, meaning if you have them built in a triangle, you can tell what direction the wave front is hitting the detectors as it passes through them. So what I'm saying is right now we know that there's like a jiggle or a wiggle or a wave that ripples through space-time itself. So what I'm saying is if you have something energetic to the size of the entire universe in a waveform, strike another waveform just so, those two strikes would tear or rip asunder space-time itself and create a new direction. Just like if you had a piece of paper with two directions of length and width, and you propagated a wave on one side and a wave on the other side, and they hit each other and they amplified each other and they snapped, they would now break into a height level. And then the math is that this happens over and over. At least there's a symmetry for this happening over and over, where as you amplify the number of directions and add one more direction each time, there's a formulaic expansion of spatial and temporal dimensions.
Wow. Oh, wait, sorry. Wow. Sorry.
Nice. Good play. Good play. I like it.
Yeah, no, it's mind blowing.
Great. I'm so happy you pulled that haiku out today, because that was a perfect moment to pull in the callback. It's just fabulous. So, all right. So other than suggesting I take my meds, what else you got? You got questions? You got holes? You want me to straw man? You want me to steel man? What do you want?
I did have one question, and then, well, yeah. So, because I've heard the phrase before, everything is a wave. Can you elaborate on that? Is it like truly everything? Like right now, I'm looking at my hands, I'm looking at a computer, everything's wave, or am I being too literal about the word everything?
No, everything is a wave. So this is a function of another of Einstein's genius moments where E equals mc squared. So the energy component is the rest energy. So we're not talking potential. It's not kinetic. It's not the temperatures. So the energy inherent in the matter itself, rest energy. So there's just the rest energy. So you have a vacuum and you have a single neutron, and that piece of matter, that little single neutron itself, has energy in it without any movement, any gravitational potential, any kinetic energy. So it has movement, it has energy entrapped in it, and the energy is proportional to the speed of light squared. So the amount of mass times the speed of light squared is the equivalent amount of energy, and we find this in nature with fusion and fission. So fusion is a sun or a star, excuse me, combining elements, and as it combines elements, the resulting new element has less mass, and there's an exchange of the additional energy that we see as radiation. And then there's fission, which is the breaking apart of matter into smaller pieces, which also releases energy just at a reduced rate. Additionally, we have these experiments that are, I think the guy's name is, I'm going to murder this guy's name, I apologize, Bruegel, Brogle, I think, or ILE, where he does these experiments with matter, meaning neutrons, that are double slit experiments. So if anybody can confirm the spelling of this gentleman's name, I'd appreciate it. But
is it French physicist Louis de Broglie?
Thank you.
Broglie?
De Broglie.
Broglie?
No, it's De Broglie. Thank you, De Broglie. Yes. So look at his neutron double slit experiments. So this guy has done, so we all know the double slit experiment where we have the duality of a photon. So a photon is both a wave and a particle, so to speak. We're not going to get too deep into this because we can go for hours, but the wave-like properties of photons are such that with a double slit experiment, you get an interference pattern on the detector behind the double slits. Just like if you had a pond and a little tiny inlet into another pond, and you throw a rock in the first pond, and it creates a wave pattern that progresses into the little inlet and then into the larger pond. When it gets into the larger pond, it creates a waveform again. It doesn't create like a little inlet size ripple. You understand? Does anybody?
Yeah.
So it propagates as a waveform. So it doesn't propagate as a single piece, even though it passes through a slit, as it were. It's inherently a wave. And as it propagates as a wave. So we have this double slit experiment. As long as you don't detect which side of the slit the photons are going through, it will create this interference pattern on the background detector. And the point is, this guy, De Bruegel, performed the same experiment with neutrons. So pieces of matter. Did anybody confirm that? I don't know if anybody can Google that for me.
Yeah, I mean, the Google AI overview, but it says, a de Broglie neutron double slit experiment refers to an experiment where a beam of neutrons is fired through a double slit, demonstrating the wave particle duality of neutrons by creating an interference pattern on a detector screen, just like light in a classic double slit experiment, thus confirming the wave-like nature of neutrons as predicted by the de Broglie hypothesis. This shows that even massive particles like neutrons can exhibit wave behavior under certain conditions.
Okay, so my contention is, experimentally, we have confirmation that both light and say, electromagnetism, which is the components of light. So light has an electrical component and a magnetic component. These are waveforms that are propagating. So do neutrons. By the way, you could do theoretically the same thing with protons. It's just harder because they're charged. Neutrons are very nice because they're neutral. They don't have an electrical component, so you don't get interference with the detector itself. The point is, though, we have experimental evidence both on the level of mass energy equivalency and with the double slit experiment with neutrons that mass has an equivalent energy / waveform component to it. So what I'm saying is everything is a wave. When we look at things as a massive particle like matter, something that has a gravitational attraction, etc., what we're looking at is a special kind of wave. It's a standing wave. Anybody familiar with standing waves? So it's a kind of wave pattern that is encircled upon itself. So imagine you have from an origin point, you pluck a string. Okay, let's just take the guitar string, and you pluck that string. You're going to propagate waves going on both sides simultaneously. Do we agree?
Yeah.
So say up and down the guitar string. So up is to the frets or the tuning thing, and down is to the
Bridge.
bridge. Thank you. And right in the middle is the origin point. What I'm saying is if you were to wrap that string around so it creates a circle, that's what we call matter. And as you clip that circle, you cut out a layer of dimensionality and flatten it. And that's what we call energy. So making the circle defines it as matter, cutting the circle and flattening it out. Because we went through the string and bell experiment, thought experiment. You guys remember that?
Yep.
Yeah.
Okay, so you can add dimensionality by creating loops in things such that when you cut them, you do not create two things. So as you cut the loop, you're not making two things out of it. You're just taking one layer of dimensionality out of it. So my proposition is, in combination of the experimental evidence of de Broglie and Einstein, stars and nuclear bombs, fission and fusion, we can put together, and the double slit experiments, we can put together a hypothesis that says all things are waves. What we mistake for physical matter itself is just a recapitulation of a waveform in a standing wave pattern that is frequency is now temperature. So matter vibrates as it is, and the vibration of matter is what we call temperature. So the faster something vibrates, the more temperature it has. So we have this inherent frequency of matter already. We know matter has waveform properties. We know matter is comprised of energy, and if you take energy, you can create matter. So these things are all interchangeable within the confines of present day experimental and theoretical physics. I'm just saying, like Einstein did once upon a time, we can do away with this whole section of physics called particles, just like he did away with the ether. I don't know if you guys are familiar with what I'm talking about.
Vaguely.
So once upon a time, there was this concept of ether, meaning scientists understood there was a wave component to light. Okay, light had frequencies. So this goes back to Newton. You pass white light through a prism, you get a rainbow. Each of the constituent components of white light has its own frequency. The longer it is, the more red. The shorter it is, the more blue-violet. But scientists proposed if there was a wave, it had to propagate through what? Some medium. And they call that the ether. So the speculation was that there was a universal ether that allowed for the transmission of light through space, a vacuum. And what Einstein did is he did away with the concept of the ether altogether. Everybody's arguing about what kind of ether is, how to detect it, where is it, what direction is it going, are we flowing through it this way or that way, does it flow through us? And he said no. What we have is space-time and the propagation of waves through space-time, curvature of space-time, We don't have to create a medium of transfer, because it's very, like when we talk about waves, it's very important to model correctly. Meaning, let's say you go to a flat pond and you drop a giant boulder in the middle of the pond, and you create this circular wave that is going to hit the shores, right? But the atom, or the molecules of hydrogen and oxygen that create the water molecules themselves, the water molecules that got struck first by that rock you threw in the middle of the pond, that's not what hits the shore, right? The one molecule bounces into the next and then kind of stays put, and then the next one bounces into the next and stays put, and then the next one. What ends up, you get a transference of energy that propagates through the medium itself, but the medium does not move. I mean, it does a little bit, but this is an approximation, obviously. So you get my point. When I snap a rope and I propagate a waveform, and it goes, and you're holding the other end of it, and it goes to you, the little piece of rope near my hand never moves, but up and down. It doesn't move along the line of string itself.
Yeah.
But the energy does. So we end up with this tension, pun intended, of we see the movement of these waveforms, but we don't see, or we didn't in the past, see the material with which it's propagating through. So there was this giant assumption for hundreds of years of ether. And it took Einstein to do away with this concept of ether that allowed us to get to the truth of the matter, which was that space-time is like a fabric. It itself wiggles and it propagates. And so back in Einstein's time, in the very beginning, the universe was thought to be static. It was not thought to be expansionary. It was thought to be, relatively timeless and in place. And it took, a lot of experimentation. And by the way, this was the curvature of space-time was verified through eclipse observations, being able to detect starlight from behind the sun. Not sure if you guys are familiar with this, but there are these celestial artifacts. I think they're called Einstein crosses. These are farther out that we detected more recently, but you'll have gravitational lensing of entire galaxies that create these images, these false images of what's behind or to the sides of these gravitational lenses in the universe. So we have multitude of layers of confirmation, experimental confirmation, that the universe is curved in its fabric nature, and that what we consider massive things at bare minimum have a wave-like component, if not are completely waves. I'm trying to do away with anything that is matter in and of itself and try to get to everything as a wave. So that's a little bit added on top, a little bit of a rant there. But I think as soon as we can get away with, there's a difference between a mass and energy, and just say energy is all things, and how energy is shaped or how it's bound together is what kind of form you see it in, whether it's wave-like or particle-like, but it's all energy. That's my contention.
Well, I'm thinking of it this way. So you take energy as a vibration along a string, let's say, right? Well, when you take a section of that string and you connect those two ends, that wavelength is now going to run into itself and cancel certain things out and amplify other waves. It will no longer be the same wavelength. And depending on how those waves cancel out, you're going to get a different waveform that then becomes matter. Because when you're canceling some of that energy out, when it's hitting itself, you're essentially lowering the amplitude and allowing it to become less energetic but contain mass.
And is this because again I go back to like, so I'm sitting here looking at my hands. I'm holding my hands up in front of my eyeballs, and it's just like it seems. I think both of you guys are saying the same thing. It seems like these are. I mean, I can squeeze my hands and everything. I can assume that it's like actual physical matter. You know, I can't like put my index finger through the palm of my other hand.
But that's due
But
to
that's just because of
electromagnetism.
the way the actual waves themselves are
What
bumping
happens when
into
you
each other,
put
right?
what happens when you put two magnets that are both north pole near each other?
They repel, right?
Yeah. Yeah. It's not exactly. I mean, Tucker's more correct on,
Electromagnetism being the thing.
You've
Yeah,
never actually touched anything. You've just touched the electromagnetic field around something.
I believe there's something called, there's like this Pauli exclusion principle where electrons more than two cannot maintain the same location at the same time, and there's like this, to Tucker's point, you don't actually really touch anything. I mean, not really, because you're bumping up against the field energy of the other thing. And but I have two ways to go. First one is flatland. So if you guys remember flatland, I'm trying to, because I think, Johnny, you said it right when you said, I'm looking at my hand. Okay. And so if you go to flatland and you think about being in the paper, you're two-dimensional, you live in the paper itself. So you have north, south, east, west, you have no up and down.
Right.
When you look at a circle, and by the way, I'm defining circle from an up-down point of view. What does the circle look like in flatland?
Like, just to make sure, like almost like the Carl Sagan example where an apple is going through, but you're saying a circle, but it's like a circle that if I was three-dimensional, maybe the circle's facing me. It's like I would see 2 points, right? Am I visualizing that right, or
A line. Yeah, you'd see a line.
Okay, so the circle is flat on the flat, not perpendicular to the right.
Well, you could take an apple and pass it through a piece of paper. It would start as a tiny line or a dot, and the line would grow until it hits the maximum diameter.
Oh, you know what? By the way, you said circle, and I just pictured like an open circle, like a donut for some reason. That's why I said 2 dots. But yeah, like a solid circle. Yeah, the line.
But very importantly, you wouldn't see the internal circle. So you're in the paper. You can only see the outside, but you don't see nothing defines itself more as if it's closer to you or farther away. Maybe the line weight or something. But so trying to get back to the reality of this thing, but just so I'm super crystal clear. So you pass a ball through a page, but not ripping it, but just like, it just sinks through the page. If you're in the page, you are part of the page. You do not recognize the shape of that thing. You see a line. Mm-hmm. Everything is aligned to you, right?
Right.
Because you can't see what's behind the line. There's no depth of what's behind the line. It's blocked. You're essentially losing, you are visualizing you're essentially stuck with one dimension because there's a level of dimensionality that is taken up with the transmission of the information. You can't see what's behind something. So we're stuck in the same situation. You're looking at your hand, and just like if you were flatland and you were three-dimensional, you could see that there's an actual circle there going through the paper, whereas the other creature in the paper only sees a line. What I'm saying is you would see your hand as a as an object that is quote unquote solid. It is line-like. It doesn't look like it has wave properties, doesn't have frequency. But if you had another up and down that you could turn your gaze to and look down upon our paper, as it were, your hand is paper. Now it becomes hollow in a way that you are unaware of, just like the person in the paper is unaware that a circle is passing through the paper and not a line. So this presupposes higher dimensionality, which, we kind of started this whole thing off by. So they do tie together very, very tightly. That you have to be able to visualize additional dimensionality with which you could look into. So go back to these quadrant systems. So if we have length, height, and width are 3 directions, and they make along positive length 4 spatial dimensions. And we are, meaning humans and matter, let's just say, are stuck in positive length, positive height, positive width. So when I talk about a loop, Tucker was saying, like the line turns into a circle. I am saying that, but it's not a one-dimensional line or one-directional line. It is a multi-directional line. It is a 3-directional line that forms onto itself. And you can't look into that thing to see its wave-like behavior, even though it's looped on itself, from within positive length, positive height, positive width.
Yeah.
If you were able to look around from, say, positive length, negative height, negative width, now there's a new direction you can look into or down to, right? So you have that quadrant system. So take yourself out of the upper right-hand quadrant. By the way, these are all superimposed upon themselves, but we're just disentangling them for identity purposes. But imagine you're stuck in that upper right-hand quadrant. So when I talk about positive length and positive height, what I'm talking about is an oscillation above or below a zero line. So the whole concept of this dimensionality is presupposed on wave theory. So the wave theory is this oscillation of a line into a higher and lower point. So you have a string, and if you snap that string up and down, propagate a waveform into it, it's still one string. Like its length has not changed. But now you've created a peak and a trough.
Mm-hmm.
Right? And so what I'm saying is we have this peak and trough situation along 3 directions simultaneously. And when you're within 3 directions, it's akin to being in a piece of paper and looking at a sphere going through it and seeing a line.
Yeah.
So you cannot see physically, not that you're incapable as a bad person, but it's not possible for anybody.
Our species hasn't evolved to be able to see that with our eyeballs or really be aware of it, I guess, or maybe there are some, like we were talking about, maybe there's some 6th or 7th, or I guess it would be the 6th sense, but some other sense to perceive this, but certainly not our vision.
Certain paradoxes allow us to indirectly realize the implications of these paradoxical situations, like the double slit experiment. Double slit experiment is a perfect representation of a paradox that we can't just visualize with our own eyes normally. It's these electromagnetism, the fact that nothing blocks magnetic fields, just like nothing blocks gravitational fields. But I could shoot a beam of neutrons at a lead shield or X-rays. Let's go to X-rays. It's easier. They both work, by the way. But I did this. I've told the story a couple times, but my wife is a veterinarian. We had an X-ray table, and I'm not the first one to come up with this, obviously. This is known for probably centuries. But a lead apron has lead atoms packed so tightly together at such a high density that if you shoot a certain kind of light at it, so X-rays are photons, they're kinds of light with a certain wavelength. If you shoot X-rays, which normally can pass through soft tissue, like your skin and flesh, and are blocked by harder densities like calcium in your bones. These X-rays are blocked by lead aprons completely. The light will not go through it at all. So X-ray light will not go through lead aprons. Magnets go right through lead aprons. So the magnetic field of one magnet, and I'm talking just like kitchen magnets. I'm talking like fucking MRIs or anything. I'm talking a kitchen magnet on one side of a lead apron, a kitchen magnet on the other side of a lead apron will stick together as if it's a piece of paper in between them. Okay? So riddle me this. How do you transfer force, electromagnetic force, from one magnet to another through a substance that blocks all light?
Yeah.
Fuck your brain. There you go. So what I'm proposing is there's a path around this area that doesn't have to do with positive length, positive height, positive width. There's an oscillation event going on where it's oscillating into a different direction or dimension, if you will, that allows it to bypass as if it's not there. Literally, so if you go back to the piece of paper guy in the circle, you can look into the circle and say, you know what, there's a book inside the circle, and I'll read you the name of the book. And then you go up little Flatlander. Let's say it's not a circle. Let's say it's a cabinet. You have a kitchen, you have a cabinet. I'll tell you what plates you have in your cabinet. You go open up your cabinet and I'll prove it to you. So anything you think is closed, I can see inside of it. I can tell you what's inside every single thing you own. I can tell you what's inside your body. I can look down upon you and you are open to me. And what I'm saying is, if you propose a higher or a new up and down, get away from dimensionality. I think people just have a bad connotation like conspiracy theory or something.
Oh.
Just adding another up and down. So hard to think of adding another up and down, but it's so simple to do. So from a piece of paper, you add north, south, east, west, you add up and down. Well, imagine you have north, south, east, west, up and down, add another up and down.
Yeah.
That's all you got to do. And in this new up and down, I propose all of matter would now look hollow. And you would see its waveform, back to Tucker's point, connecting with itself, making a solid that you see from the outside. So back to you looking at your hand. Bob, it looks so solid. How is this a wave? Well, you don't have another up and down to look down into it. But if you did, and if you had a microscope so you could look deep inside, because obviously your hand is made of, atoms and molecules, stuff like that. So, but if you could look at the micro level from a new up and down, I propose you will see it is a waveform trapped on itself. But it's not just length looped around touching itself. It is length and height and width. So it's hard to understand this. You really have to get electromagnetism. So electromagnetism is a waveform. Let's take X, Y, and Z. So X is length, Y is height, Z is width. So electromagnetism is, and by the way, you should be able to find this. There's a really nice GIF online about the dual waves propagating out of phase that create electromagnetism. It's very, very cool and good to look at. So you have a length along X, and then you have a propagation of a waveform along Y, and then out of sync. So not at the same period. It's alternating periods. You have a simultaneous waveform along X going in the Z direction. So you have a single wave propagating both up and down and left and right at the same time, but they're out of phase by one series. So you have a waveform where it's a peak, then it crosses the zero, then it's a trough, then back to zero, then a peak. And alternating out of phase is a left to right waveform.
I see it.
That is electromagnetism. Now, what I'm proposing is, if you loop that around, so if you make a circle out of that thing, just like out of a magnet where it goes out of the North Pole, loops around in a field and comes back up through the South Pole. And this has to do with spin of electrons, by the way. So very, very interesting topic we should get into, which is chemical bonding. There's 3 types of chemical bonds. There's ionic, covalent, and metallic. Metallic bonds create this effect of shared electrons that behave in a polarized manner when magnetized. And not only are they orbiting, but they're spinning a shared group of neutrons and protons. So metallic objects in the periodic table, they have electron shells, and you get a certain number of, like iron, that have very low electromagnetism on their upper shells. So the closer the electron is to the nucleus, the tighter it holds itself to the nucleus. The tighter the the electrical force is, the higher up, meaning you're not going to lose, like oxygen will rip away electrons from other atoms. So oxidation is the ripping away of electrons from another atom to make ions. Metallic bonding is a collection of protons and neutrons at the center, and then they have high shells of electrons that are loosey-goosey. And part of the nature of metal, as you well know, is you can smush it together. It's ductile. You can draw it into a string. You can smash it, and it doesn't break. It kind of like flattens up. So you have this like squishy, liquidy center of all these nuclei, and then the outer shells of their electrons form like this fluid that's shared by all the atoms in the bonded metal substance. And if you polarize or align the orbit and the spin of those electrons, that's what magnetism is. So you take a polarized flow of electrons that are shared amongst all the atoms, so they do get to transfer. They're not possessed by any one quote unquote atom in a metallic bond. They become like this fluid. And what I'm saying is they're wrapped around. They're moving in an orbital pattern, and they're spinning. So they're moving in an orbit and spinning. So imagine you're looking straight down on a top, and imagine it is orbiting or processing in a counterclockwise manner. And as it's counterclockwise spinning in an orbit, orbiting, its spin up, spin down is rotating over and over and over again. But you align them all, you get them all polarized, so they're all the same. You put one of those on one side of a lead apron and the other one on the other side of a lead apron. And what I'm saying is that waveform that you just looked at, John, electromagnetism, when you loop that around, the magnetic component of that is touching another dimension. So it is going into the negative width, positive height along positive length, and negative width, negative height, and negative height, positive width, back around to the positive width, positive height, positive length. It's making a circuit circumnavigating the lead atoms. That's how it's able to touch itself and create a force through something that should be blocking the force of the light itself.
It's like so gnarly to think about, and it's
but I
so
think there's a
cool.
lot of proof out there. I think there's a lot. So I don't think it's as woo woo. I mean, I do need my meds, so I'll get that soon. But I don't think when you combine all these effects that I've recognized and found, which I don't claim any experimental knowledge other than the lead apron thing, which I did myself personally. And by the way, there is no blocking. If anybody has a question, there is no block to magnetism. You cannot block magnetism. The only thing you can do is wick it away inside a Faraday cage. So if you had a bunch of conducting material like copper, you can stop a magnetic field from propagating outside of the container, but you're not blocking the field. You're just wicking away the fact that there's electromagnetism. It's literally unstoppable. It's like a force that cannot be blocked by any physical means, whether it be lead or wood, flesh, anything. Nothing stops it. So MRI machines look right through you, look right through anything, quite frankly. Just like gravity. Gravity is one of these forces that is in a field that supersedes what we would consider a physical bond, a physical block. So there's nothing that stops gravitational fields because it's literally the curvature of the fabric of space-time itself. So understanding these fundamental key experiments and putting them together in the right model is what I'm bringing to the table. I have a model that I think is best explanatory compared to the standard model of, you know, how the universe works in these specific instances.
Yeah. Fascinating. Is this we're probably at time we could wrap up here, but I noticed in your notes you'd mentioned kind of a part 2 about quantum entanglement. Is that something
Super
you want to
quick.
go
Yeah.
to like next
Yeah, let
time
me hit it.
or this
No,
time?
let me hit it real quick. It's
Okay.
super simple. I think it's perfect timing. I'm glad you brought this up. So imagine you have a quantum entanglement event. So a quantum entanglement event is like plucking your guitar string, and you have one waveform going up towards the tuning board and one going down towards the
Bridge.
bridge. Thank you. So imagine if you measure where the waveform is at a given point on the bridge, you will know where the waveform is going towards the tuning pegs, meaning it's either going to be positive or negative, so either above or below the zero line. And in reality, it's usually spin up or spin down. That's the definition. But we're not going to do spin. We're going to say the wave is either above the zero, so it's either farther away from the deck of the guitar or it's closer to the deck of the guitar, right? So positive will be away, negative will be towards the deck of the guitar. So you do one pluck, and now you have these two waveforms propagating in opposite directions. They're quantumly entangled. So when you measure the one, you instantly know what the other one is.
Okay.
Now it's a probabilistic situation. You don't know what it is until you measure it. And once you measure it, it collapses the waveform and you remove all probability. It is maybe 50-50 spin up or spin down, or above or below the zero line. But once you measure it, if this one is above, the other one's below every time. If this one's below, the other one's above every time.
Mm-hmm.
Okay. So imagine you have a line and you propagate this quantum entangled situation where you have two particles moving away from each other. I'm proposing that there's, say, a parabolic shape, like a line drawn in a parabola. And if you can imagine the very top of the parabola as the point of impact when you pluck the string and you propagate the two waveforms going in opposite directions. And then imagine drawing the parabola like you're holding it, you pulling it up. And as the parabola intersects the line, the 2 points are spreading out, right? So the parabola is, you can see both sides of the arch, as it were. They're going to get farther and farther apart from each other, right?
When you're pulling it up, you said?
Yeah. So imagine you're pulling it up through like a plane. So the very top of the parabola, the apex of the parabola is the origin point. But as you pull it up, the parabolic shape is going to intersect through that plane in 2 points. And as you pull it up higher, those 2 points get farther and farther apart.
Perpetually?
Yes.
Okay.
So can you visualize that? So you have like a parabola. So you're pulling it up through a plane, and the point of its intersection in the plane starts as the 0 point, the origin. But as you lift it up through the plane, the parabola is making an arch with ever expanding base, right?
Mm-hmm.
So that's the two quantum entangled particles, let's just say, for hypothetical purposes. You're pulling this parabola, this arch, let's just call it an arch. So, but the arch is forever getting bigger, meaning the base is infinitely big, right? So as you're pulling up the arch through the piece of paper, you're showing a wider and wider base. Everybody see that?
Yeah.
Oh, yeah.
Okay. So imagine this. Imagine, because this is the paradox, is spooky action at a distance. That was Einstein's terminology. When you measure the one, so let's say we measure one side of the guitar string, the other one is instantly known. It's no longer probabilistic, but it doesn't matter time or space. So go back to the sophons in Three Body. They would communicate 4 light years away to the home planet instantaneously. So it defies the laws of physics that the speed limit of the universe for anything is the speed of light. So the one thing Einstein couldn't explain as far as speed of transmission goes is quantum entanglement, spooky action at a distance. So what I'm proposing is you have this parabola that's connecting the 2 points, but imagine it's going in a different direction, a new up and down that we can't see.
Yeah.
And imagine this parabola expands, so wider and wider base as these points diverge. And if you flick one side, say you just push it, imagine there's like a post right in the middle of the arch. So it's on like a not a swivel, but it's on a dowel, okay? Like you could spin it from the center point. If you can visualize from the plane up through the arch itself, the center point of the arch, the top part of the arch, the parabola, there's like a rod connecting it. So you could spin it. So if I push it like
Do you mean sort of like kind of like the cross section of like an umbrella, maybe like the umbrella handle is sort of that dowel?
Yeah, perfect. Yeah,
Gotcha.
we could do that.
Okay.
So you have let's just say the umbrella component, the top component with all the spokes, right?
Yeah.
So the spokes are crossing through, and if I were to take my finger and move one of those spokes a little to the left, the corresponding spoke on the other side of the umbrella would move to the right.
Yeah, I see what you're saying.
Instantaneously though. Like as I move one, because it pivots on the center point.
Yeah.
So it doesn't propagate as a wave. It literally pivots. So if you were to like flick or push one side or one thing, it's literally going to be, say I'm going to push it to the left, then the other particle going quantum entangled the other direction would go which direction?
The opposite direction.
Yeah, it'd go to the right. So if I push this one to the left, it would be like a weather vane, right? So you have a weather vane as it gets pushed, the tail of the weather vane gets pushed to the left. The top of the front of the weather vane would go to the right.
Yeah.
Vice versa. So that's simple as that. So there's another direction that these particles that are quantum entangled are connected by. And it's another up and down direction that we can't see in. But if you touch one to go one way, you want to push on it, you measure it, whatever it is, it spontaneously executes the opposite on the other quantum entangled particle. So it goes back to the dimensionality thing. That's it. That's the whole thing, by the way.
Yeah.
So
Okay.
that
is fascinating.
But you have to have, the I won't say faith, but I will go back to, contact and drawing a distinction between scientists who think they're objective when they're really, there's there's a lot of things out there that they claim to know that are not really the same classification of what we would consider like, water is wet. I know that kind of a thing. I'm just saying I'm in the same realm, I propose, of speculation that a lot of mainline scientists are with their explanations, if that makes sense. Instead of trying to elevate myself, I'm trying to pull them down a little bit. Say there's a lot of speculatory theories going on and hypotheses. And I just contend that we don't have everything figured out. Yeah. Be open-minded. Be willing to say what if,
right,
and see if there's a more a better fit to a different model that explains the same set of facts. I agree with all the same facts as all the mainline scientists. I don't disagree with any facts. I'm just saying there's a more perfect model that explains the coupling of all these disparate facts together that I think is superior to the standard model.
Yeah. I think that's an encouraging thought too. I mean, it's a good place to wrap up too. But like, yeah, just that we would have to be quite, I don't know if prideful is the right word, but like hubris, right? Like to just think, we figured it out now. Like, hundreds of years, thousands of years of having it totally wrong.
But many
killing people for like disagreeing with like the standard.
People said they had it figured out. That's
what I mean. That's what I mean.
Yeah.
I mean, like, so at this point, like, do we really think we've got it all figured out now? Because why, we're alive now? Like, really? Like,
the cell phones. If it weren't for cell phones, we would have so much uncertainty.
yeah, because you could Google it, right? You could just Google.
You could totally Google it. Yeah, you could call bullshit on everything just so you talk. Satellites, right? Telescopes, satellites, particle colliders, yada yada yada.
Yeah, certainly closer to things, but yeah, I appreciate the. Will we ever really know until truly like we're maybe restricted by our evolution, right? Like so far this is just the best we can say for sure, but I like the idea that there's more out there that we just flatland that we just haven't evolved to be able to perceive yet.
Well, let me do a poll on you two guys. You're my sample audience. Now that you've had a chance to digest a little bit of these concepts a couple times now, and standard school science and Discovery Channel shit and regular standard model stuff, just as a story, just as what sounds, Big Bang, something from nothing, God, alien on his laptop, Bob's, everything's a wave. Which one of those, if you could, rank or just kind of put them, just personally, subjectively, just, you're not going to hurt my feelings. I'm just curious. Where do you rank those or put those as ideas?
It's a better story than Jesus did it.
Yeah,
I'll take that.
Here's a direction my mind went during this conversation. I was thinking about Einstein's equation, right? And I did quick back of the envelope calculations, and I'm now convinced that I was originally 6.27 trillion joules of energy that somebody observed and collapsed the waveform on, and now I'm stuck in 180 pounds of meat.
Fair.
Nice math.
Which 6.2 trillion joules, that's like a third of an atom bomb, that's.
Oh, you would go boom. If we could split you and put you into energy, you would go go big boom. Yeah.
Yeah.
But just think about this, like the Star Trek replicator. Think about how much energy they pumped in just to make like a taco or a cup of coffee.
Earl Grey tea.
Or yeah, thank you. Earl Grey tea. Shit, I missed that. My bad. Sorry, Picard. No, but I think that's a great point. I mean, we are that thing trapped in this weird flesh suit. But just think about the amount of energy inside your body is just preposterous, honestly.
Yeah.
Just like back to Sagan or star stuff, right? I mean, we are literally.
Well, and that search led me on a different side path where I found a note that said that every second the sun is converting 6 billion pounds of matter into energy.
That's a lot.
That's a lot.
And it's been doing that for a couple billion years, like 3-4 billion years, maybe 4 billion years, I think. Yeah. I mean, where everything other than hydrogen and helium in your body came out of a star. I mean, probably the hydrogen and helium too, just being honest. But I mean, everything was created through fusion. All the higher periodic elements had to have come out of a star.
Well, and think about this from just a philosophical perspective. It's like, okay, if you go back far enough, we're all from Africa. If you go back even farther, we were all sponges. If you go back farther, we were all stars. If you go back farther, we were all hydrogen. And if you go back farther, we were all energy.
I love it. Exactly. I mean, that's very poetic and beautiful, but yeah, I mean, you can't escape the fact that as far as the timeline, we are at such a small level of the timeline to think we figured this thing out.
Right. Yeah.
Is filled with hubris. I mean, that's the only way you can say it, honestly, is that this, to unwind what Tucker just did, the opposite order, to say like energy eventually figures out it is matter. What? Like maybe energy eventually figures out it's really just energy again, just in another form. I like it. I like that a lot.
Yeah, I mean, as advanced as we are, I mean, we only put a fucking airplane in the sky 100 years ago.
Yeah.
But we did go from an airplane to man on the moon in 69 years.
In 60 years,
Yeah.
Good point.
Impressive.
Well, what do you think, John? Where would you weigh in? Are we?
In those things. Yeah. Yeah. I mean, like, I think I'm less inclined to settle on something. I love hearing the ideas. I think I have more enjoyment like hearing the ideas than and trying to ask questions and trying to wrap my head around all the things than feeling confident that I even confident in ranking. I know that's kind of what you're asking, like between these. I don't even know if I feel confident saying like, well, this one seems more feasible than that. I just don't think I
think he
I don't think I wrap.
I think he's telling us Jesus is the what? No, I'm just kidding.
Yeah. No, it was Joseph Smith. Remember, like that's what
he was the right.
Yeah. But yeah, no, it's I don't know, man. Yeah, really, when it gets to this stuff, I'm just in a interesting way. I feel like so out of my element. I'm happy to be involved in the conversations, but I don't have a lot of confidence saying like, yeah, this one seems like feasible because of XYZ. The XYZ, the justification, like that doesn't come easily to me at all. You know what I mean? It's very like you're saying you're gonna get meds, and I'm like, what am I gonna do here to like unmelt my brain for the rest of the day? I'm gonna like go and sit and just like.
Can I say that? Can I? I appreciate that, by the way, and I think that's a fully acceptable answer to me. But can I make the point that they're all just stories?
Yeah. Well, and I'm a big proponent of just the idea of stories. It goes back to that stereotype quote. You know what I mean? Like but yeah, so I can appreciate that. Yeah, they're all stories, especially for me, especially like my perspective is I'm just hearing these stories. Again, I don't have confidence saying like this one is the right one. You know what I mean? So I love that. I love that aspect that they're all stories anyway. And I'm an observer I'm reading the stories or listening to the stories.
But maybe it would make a good story if compiled into a artificial narrative that allows us to explore different human interest topics. You see where I'm going with this?
I was going to say, could you possibly be hinting at something you might be working on? Yes, no, but yeah, beautiful. No,
does it pass the smell test to at least be in the running of like compelling narratives that you would invest time in, absorbing the content of, or is it just so outlandish that it's like a waste of everybody? It's like, well, Bob, they're magic, ass fairies, and they're dingleberries, and they cluster around Uranus, and they make it go around. Or whatever. I mean, I'm just saying it's within the realm of like we can take it and make it something beautiful.
Definitely.
It's got more meat to it than most popular sci-fi does anyways.
Yeah. I was gonna, I don't know what I was gonna say. Like,
by the way, I really appreciate that, Tucker. I really, really appreciate that.
Yeah.
Because I mean, think about like Star Wars and how big that has gotten, and it's like there's no scientific meat behind that story at all. Like
dilithium crystals, my
shit just happens.
Yeah.
Dilithium crystals and
warp speed and
midichlorians
stuff.
or what are they?
I mean,
Yeah.
at least in Star Trek, like they reference like inertial dampeners, but yeah, like in Star Wars, they're sitting in the Millennium Falcon and they jump to light speed and there's no inertial effect. And they don't, again, like I don't,
Mhm.
maybe in books, maybe in some of the like Star Wars novels and stuff, maybe they get into that, but in the movies and the
Man, their space
shows.
lasers make noise.
You can see them progress, right? You can see
Yeah.
the little
Yeah.
the blip go. Yeah,
Yeah.
it's a good point.
Yeah. So I think all that to say, yeah, like a good foundation. I mean, if you're gonna like tell a story and come up with like a narrative of, you know, any, especially science fiction, like a good foundation is, oh, what a great place to start. And yes, definitely feel like you're establishing a great foundation for,
It's plausible. You're saying it's
Yeah.
plausible and
Yeah.
it's compelling in that it can't be disproven or whatever.
Yeah.
I like that.
In the way that I think that's what I appreciate a lot about like Dan Brown and Andy Weir. When I read their books, I'm just like, this just does seem like it's less of the, like we were just talking, less of the Star Wars kind of just, it just happens, go with it. I would say like Ready Player One. I love that book, but there, that wasn't really what the author was going for. Was like a feasible, plausible type of. It was just accept that this technology exists, and then here's the story. And I think what you're doing is like really trying to get that foundation of like feasibility, plausibility to build from. So yeah, I
By the way,
admire
I
that.
really liked Dan Brown's stuff back in the day, but that dude pissed me off.
Oh, with Inferno.
Yes.
Well, with the follow-up,
Well,
after
yeah,
Inferno, right?
and the movie, because first of all,
sure.
in the movie they changed it to a happy ending, which the book
Yeah.
did not have. But then he wrote another book in the same universe and pretended like he didn't just sterilize 50% of the population in his last
I think
book.
it was 30, but yeah, I think it was like 30, right? 30%. But anyway, but no, yeah, like no reference at all.
No reference,
It
never
was
happened.
very interesting. It was like, yeah, it's no continuity there. That you kind of would have. I think you would have appreciated. That's what you're saying. I would have appreciated it. It was like these are standalone books, but this, which worked in the previous ones, but yeah, Inferno was like this major global massive thing that happened, and then like you said, the next one's like,
Anyways,
or did it? I don't know. Yeah. I don't know. Did it happen? I don't know.
Yeah.
Well, right on. Well, yeah, excellent discussion here. So we'll figure out exactly what we want to do next week. I know we got a few things in the hopper here, but yeah, I think it's a good place to wrap up. I was going to ask ChatGPT for a quote about physics and dimensionality. Nothing obvious comes to mind. Sometimes we've done this and been like, it's going to do this, right? Nothing obvious comes to mind, so this could be interesting. But yeah, thank you guys. Thank you for listening. We'd love to hear from you, so please send us an email. Sendingpost@gmail.com is the best way to get a hold of us. And so here we go with ChatGPT. Give me a quote about physics and dimensionality. Here's a thought-provoking quote about physics and dimensionality. This says it's attributed to British astrophysicist Sir Arthur Eddington. It speaks to the complexity and often incomprehensible nature of the universe. How fitting, particularly in the context of modern physics and higher dimensional theories. Eddington's reflection captures the mysterious, multidimensional aspects of the cosmos that extend beyond everyday human experience. So that's interesting. Okay, here's the quote. Not only is the universe stranger than we imagine, it is stranger than we can imagine.
I'm going to read one that came up when I was looking for the Tesla quote earlier, and this, I may have to look into this guy some more because he's got a book or two out, but he says, the universe is energy, vibrational energy. All energy vibrates. All matter is energy that is slowed down enough so that we can see it and touch it.
Yep.
Nice.
Who is that?
Yeah.
by the way?
David R. Hawkins.